All right, guys, before we get started, are there any questions on homework? Any questions on the homework assignments? All right, guys, so what we're doing today is solving logarithms. These are going to be very similar to what we did on Thursday, but the only difference is that instead of having one log, we have two. Whenever we have two or more logs, we need to get them on the same side, and we need to rewrite them as a single log. And we can do this because of one of our properties of logarithms. That's stated if we have two or more logs being added together, we can rewrite it as a single log with what's inside being multiplied together. So our log base b of m plus log base b of n is the same or is equal to log base b of m times n. We have a similar property as if they're being subtracted, but instead of writing them as a multiplication, we write them as a division. Log base b of m minus log base b of n is equal to log base b of m over n. And the reason that this is helpful for us here is because we can rewrite log of 2x plus log of x minus 5 as log of 2x times x minus 5. We can rewrite those two logs as a single log. And we have to do that for us to be able to solve. Well, once we get it to this point, the rest of this is going to be exactly the same steps as, for the most part, as what we did on Thursday. Now, the next step would be to what? Put both sides to the base of. Because what is our base? Because remember, whenever it's not written, it's understood to be 10. If it's natural log, it's understood to be e. So 10 to the log base 10 for this here would cancel, leaving us with 2x times x minus 5 is equal to 10 to the second power. Questions on this here? Now there is some stuff we need to simplify. One of them is our 10 squared, which is 100. The left side will need to distribute the 2x. 2x times x, 2x squared. 2x times negative 5 is negative 10x. Now, since we do have a quadratic term, an x squared term, we need to get this equal to 0. And we can do that by subtracting 100 from both sides. So the left-hand side would be 2x squared minus 10x minus 100 is equal to 0. Either one. Which one do we want to do? Do we want to factor or graph? And graph it. So we'd say 2x squared minus 10x minus 100. And we can hit graph. So we do see that it crosses one side on the left side of our y-axis, probably somewhere around negative 5, negative 6, or negative 4, somewhere in there. And it does cross on the other side close to 10. So if we go second table, so negative 5 is one value of x, that'll make the y value be 0. And the other value is indeed 10. Because with our quadratics, that x squared term, we should expect two solutions. Here it works out one of them is -5 and the other is 10. Now for these here, especially when we have to use our product property or our quotient property, we do need to check our solutions, because what's inside either of these logs cannot be negative or 0. So what I'm going to start off with is 10. So we're saying log of 2 times 10 plus log of 10 minus 5 is equal to 2. Well, here we'd have log 2 times 10 is 20 plus, well, here we just have 10 minus 5, which is 5. We see if this is indeed 2. Now, since it is a common log, try this the third time, what we can do is say log of 20 plus log of 5. It is indeed 2, so that works. We can do the same thing for our other one, -5. So we'd have log of 2 times -5 plus log of -5 minus 5 is equal to 2. Well, our 2 times -5 is -10. -5 minus 5 is indeed -10. And again, we can check this here. Log of -10 plus log of -10 is domain error. We cannot have a negative number inside our log. So our 2 times -5 gave us -10. We can't have that -10 inside the log. And the same for our -5 minus 5, because the number that we ended up with in both of these cases was -10. It means the value of x cannot be -5 for this here. It has to be 10. So really, when we're checking our solutions, we're trying to make sure that, in this case, 2x and x minus 5 did not give us a negative number or 0. Because if either one of those was negative or 0, it wouldn't work. Yep. As it's not always going to be the case that negatives don't work. It's just here, neither one of those ended up becoming positive when we plug it back in. Questions on this here? Log base 6 of 6x plus log base 6 of x minus 1 is equal to 2. First step on this here is we need to turn these two logs into a single log. And since they're being added, we'd have it as 6x times x minus 1 is equal to 2. Now what are we going to put both sides to the base of? We wouldn't use 10 this time. We're going to put 6 to both sides because they did give us a base, and 6 to the log base 6 would cancel, leaving us with 6x times x minus 1 is equal to 6 squared. 6 to the second power. Well, what is 6 to the second power? 36. On our other side, we can distribute 6x times x is 6x squared. 6x times -1 would be negative 6x. Yes, we would subtract 36 from both sides because, again, since we have an x squared term, we need to get this equal to 0. Anytime we have a power greater than 1 attached to a variable, and we have other terms, since we have x squared and x, we need this equal to 0. Now again, at this point, we could factor it, we can graph it, we could use the quadratic formula. Any of these will work. And if we graphed it, we can type this in, 6x squared minus 6x minus 36. And we do see that it crosses at 2 points, which would indeed be 3 and negative 2.
So it could only be 3 because negative 2 is 3.
Yes, because our 3 in the two places it shows up would be 6 times 3, which is 18. It's positive and it's not 0, so we're good. Our 3 minus 1 is 2. Positive and not 0. And again, we could type these in and it would verify that those are indeed the correct answers. 6 times negative 2 is negative 12. We can't have negative 12. And negative 2 minus 1 is negative 3. Again, we can't have that being negative. So the only one of these two that works is x is equal to 3. Questions on this here? Questions on anything we've done so far? We good with these here?
There was already I on that.
I want to change this next one a little bit. So instead of doing log, we're going to do natural log for this one here. It'll change the answers a little bit, but so yes, we would use a different base. Now the first step would be the same, because we can rewrite these two natural logs as one, and it would be 5x times x minus 1 is equal to 2. So that's the same. We would still apply a base to both sides, and it would be e.
Natural log is E.
Because the natural log, ln, is e. ln's base is e. Now, e and our ln will cancel, leaving us with 5x times x minus 1. E to the second power would be what? Second ln would give us e to the second power. Is that a nice number? So we're going to leave it. We're going to leave it as e squared for now. Now on the other side we can distribute. 5x times x is 5x squared. 5x times negative 1 equal to e squared. And again, because we have an x squared term, we do need to get this equal to 0. Now, if we didn't have the x term, we could get the x squared by itself and use the square root method. Questions on how we got to this point here? Well, everything looks the same except for our e squared, yes? We could, but it's not going to give us something nice because, again, e squared is an irrational number. So what we have to do to solve this from here is quadratic formula. Now for this here, we will have two solutions each time, so it's going to be a little bit easier than we've done it previous. Now we don't have to write this out every time. I'm just going to write it out here so we can see it. A, B, and C. And again, our A, B, and C come from our general form of a quadratic, ax squared plus bx plus c. So what's the value of A for this here? 5. What's the value of B? Negative 5. And the value of C?
Negative e squared.
Negative e
Dot.
squared. Because negative e squared is just a number. It's that constant term. So when we type this or plug this in, we'd have x is equal to negative b. Well, that'd be negative 5 plus or minus the square root of negative 5 squared minus 4 times a, which is 5, times c, which is negative e squared, all over 2a, which is 2 times 5. Questions on how we got those here? So even though one of the numbers doesn't look like a number, our negative e squared, it still works, still holds true. Now we could simplify some of this here, our negative 5, our 2 times 5. But what we can also do is just grab the calculator, 30xf, graphing, and say negative 5 plus second square root, negative 5 squared minus 4 times 5 times negative e squared. And on both calculators, to get e, we do second ln. Second ln gets us e every single time. And on bottom, it is 2 times 5. Type the whole thing in, and our answer is 1.814. Yeah, we're going to round to the third decimal place. That's our answer. So there are two like this on the homework, and you'll have to round for them. But for the most part, once we get it there, we just plug it in and let the calculator do it for us. Now there is one other answer, and we just have to go and change the sign in front of the radical.
It's better with the graphic tables because it's very accessible axis.
We can just put the cut over the top of it and hit minus. Yeah, if you put the cursor over the top of it, hit minus, it'll replace it. Negative 0.814. That's it. Almost, but that's pretty much it. Questions on this here?
Does it matter if you put both of those?
Well, these are both the solutions, yes?
Yeah, but minus one.
The minus doesn't work because we were talking about this being ln of 5x plus ln of x minus 1. Because the negative one will actually make both of these still be negative, so we have to throw it out. So it only works out to be 1.814. Questions on this here? All right. We're going to skip one and we'll look at this here because I think for the most part we feel pretty comfortable with addition. Because this here, the addition really didn't add much to this. Just our first step that we had to take it from the two logs being added to a single log with what's inside being multiplied. Now here, it's almost the same, but our two things that are inside the log are not going to be multiplied. They're going to be what?
Or they're going to be divided because it's a negative sign.
They're going to be divided since we are subtracting the two logs. Because if I am subtracting two logs with the same base, it's the same as dividing them inside the same one log. Questions on this here? Now at this point, we could put both sides to the base of what? 10. 10 to the log cancels out, leaving us with 3x minus 2 over 2. Now the next question is 10 to the third a nice number?
Yes.
What is 10 to the third power?
3. How do you say it?
10 times itself 3 times.
I'm doing 100 plus, well, 100. I did it in my head 100 times 300, but I didn't.
100 times 10.
I do that all the time.
Because 10 squared is 100, and then 10 cubed would be 100 times 10.
I always do just plus, and then I put it in the decimal.
Now, since our only x is to the first power 3x, we just need to get it by itself. Now, if we multiply both sides by 2, the 2 and 2 will cancel. Telling us 3x minus 2 is equal to 2,000. What would we do next? We could, but since we don't have an x squared, we don't need to do that. So since it's just x, we can add 2. Telling us 3x is equal to 2002. There we go. And lastly, we would divide by 3. Telling us x is equal to 2002 over 3. And in both cases, this actually is the final answer. Now, we wouldn't reduce it from there because 2002 does not divide by 3 nicely. And that's it. Questions on this here? I'm going to give you the rest of the time to work on the assignment.